In this video, I will walk you through free response question number 6 from the 2003 Form B AP Calculus exam. This problem is about differential equations. Let f be the function satisfying f prime of x equals f times the square root of f of x for all real numbers x where f at 3 equals 25. Part A. Find f double prime at 3. Let's rewrite the square root of f of x as f of x to the 1/2 power. To find f double prime of x, I need to take the derivative of f prime. This is a product, so we will use the product rule. The first time through, I will take the derivative of the first factor, but that's just a 1. I leave the second factor alone. And I put a plus. The second time through, I leave the first factor alone, and I take the derivative of the second factor. But this will require the chain rule. So taking the derivative of the outer function, I do the 1/2, and subtracting 1 from the exponent, I have negative 1/2. The inside part stays the same, but then according to the chain rule, we have to multiply by the derivative of the inner function. So I have to multiply by f prime. But look, we know an expression for f prime. So on the next step, I'm going to make this substitution. So now we have this. However, on the next step, when I multiply f of x to the negative 1/2 power times f of x to the positive 1/2 power, these two will cancel each other out. And then we have x times x, which is x squared, times 1/2. So now we have this. Now we can go ahead and find f double prime at 3. Putting 3 in for x gives us this. But don't forget, we know that f at 3 is equal to 25. So let's go ahead and make that substitution. This is a perfectly acceptable answer, but it's pretty easy to simplify, so here you go. Ultimately, f double prime at 3 equals 19/2. Part B. Write an expression for y equals f of x by solving the differential equation dy dx equals x times the square root of y, with the initial condition f at 3 is equal to 25. I think I will write the square root of y as y to the 1/2 power. This is a separable differential equation. So let's get all of the y's on the left and all of the x's on the right. To begin, let's move dx to the right-hand side by multiplying both sides by dx. Next, let's move y to the 1/2 power over to the left-hand side by dividing both sides by y to the 1/2 power. To make it easier to integrate, I will write this as y to the negative 1/2 power. Now that I have all of the y's on the left and the x's on the right, I can integrate both sides of the equation. For the antiderivative, I'm going to add 1 to this exponent, giving me 1/2. Then I divide by the new exponent, but dividing by 1/2 is the same thing as multiplying by 2. Normally I would put plus c, but I'm going to save that for the other side of the equation. The antiderivative of x is 1/2 x squared, and there's your plus c. Let's use this initial condition to find the value of c. This means when x is 3, y is 25. So let's make those substitutions. So now we have this. 25 to the 1/2 power is the same thing as the square root of 25, which is 5. So I have 2 times 5, which is 10. 3 squared is 9. 1/2 of 9 is 9/2. Let's subtract 9/2 from both sides. Let's rewrite 10 as 20/2. So I have 20/2 minus 9 over 2 is equal to c. But this is going to be 11 over 2. Substituting 11 over 2 back in for c, and we have this equation. When they say write an expression for y equals f of x, it means write y by itself. To get rid of the 2 in the front, we can divide both sides of the equation by 2. So that will leave us with y to the 1/2 power is equal to 1/4 x squared plus 11 over 4. Now let's square both sides of the equation to get rid of the 1/2 power. So this will be y is equal to 1/4 x squared plus 11 over 4, whole thing squared. And that's the solution to the differential equation in the form y equals f of x.